Hello everyone, welcome to Elite Learning. Today's lecture is on algorithm. Under this, we are going to learn asymptotic notation. So let me write first. Alright, so I have already discussed this problem and solution in my previous lecture, algorithm lecture. If you haven't watched that lecture, please go and watch that video first in my playlist, data structure playlist, and then come back to this lecture. Alright. So whenever we have more than one solution for the same problem, we need to compare. We need to choose among the two solutions, right? So how we are going to choose that solutions? So we must have certain criteria, right? That also I have discussed in my previous video. That is efficiency of an algorithm. So after finding efficiency also, first we need to, and then we need to compare the algorithm, right? So in order to compare the algorithm, we must have certain matrix, right? So that matrix is provided by the asymptotic notation. So generally, we can see three asymptotic notation, that is big O, omega, and theta. So first, let me write this asymptotic notation. So now we'll see analysis of asymptotic notation. So now first we'll see asymptotic notation big O. So here I have drawn small graph. So this horizontal line represents number of input n, and this vertical line, it represents time for its execution for that input. So here you can see there are two functions. Number one is f of n, and second one is function gn. So this first function, it is representing as like how the input is taken and what time it is required. So initially you can see that there is a steady line. Initially there is a steady line that for that certain input it is executing in the same time manner. But whenever the input is higher, then it is taking more time for its execution. So again similarly with the second function gn, it is behaving in a different manner. Whenever the input is higher, time is taking much more from the previous function. So let us understand with the help of small equation. Alright, after writing this equation, now you can clearly see that f of n is lesser and g of n is higher. In a graph, it is representing lesser and higher. So from this, what we can extract is that f of n is less than c of g of n. I can equate it as f of n is less than equals to c of g of n, where c is nothing but it is a constant which has a value greater than 0. So why greater than 0? Because if you replace this constant with 0, then the whole this function will be null. That means there will be no existence of this function, thus we cannot equate with this function. So therefore we have to replace this constant with greater than 0 value. Once it is done, now we can say that we can use matrix big O and we can equate it as f of n equals to big O of g of n. So this is how we can represent this big O in an equation. So I'll show you with the proof with this big O. Let us see. Alright, so here in proof I have taken two function f of n and g of n. So in f of n we have 3n plus 2, and in gn function we have n. So earlier we have already seen this big O of equation, that is f of n is equals to order of g of n. So if we can say that f of n is equals to order of g of n, or f of n equals to big O of g of n, then simultaneously we can say that f of n is less than equals to c of g of n, which these two equation is equivalent. So here f of n can be replaced by 3n plus 2, since function is given by 3n plus 2, less than as it is, and then c constant as it is, and then for g of n we can replace by this value n, so therefore n. So our equation becomes 3n plus 2 less than equals to c of n, where c is our constant. It can have a value greater than 0. Since it can have a value greater than 0, therefore I'm substituting this value of c as 4. So therefore our new equation becomes 3n plus 2 less than equals to 4 of n. So here, in order to satisfy the condition of, or equation of big O of asymptotic notation, here value of n must be greater than equals to 2. If we assume less than 2, then this condition will not satisfy this big O notation. So therefore, if we assume 2, suppose let us take an example, if we assume 2, then this part will become 3 into 2 and then plus 2. That means 3 to 6, 3 times 2 6 plus 2 8. 8 is less than equals to 8, since 4 times n is 2, so therefore this becomes 8. So therefore now this condition will satisfy. 8 is equals to 8. So therefore we can say that this function of n is equals to big O of g of n. Now we will see omega. So let me draw the graph for omega. Alright, so in this omega asymptotic notation, as you can see, function with constant is in the lower side and simple function f of n is in the higher side. So from this, what we can derive is that we can say that f of n is greater than equals to c of g of n. Since f of n is in the higher side, so it is greater, and g of n is in the lower side, so we kept it in the lower side. So therefore we can derive this equation from this graph. F of n is greater than equals to c of g of n. So let us see with the help of an example. Let us take a proof, and then we'll derive this equation. So here in proof for omega also, I have taken the same function. F of n is equals to 3n plus 2 and g of n is equals to n. So here f of n is equals to omega of g of n. As you can see from the previous graph, we can derive this as f of n is greater than equals to c of g of n. Since function f of n is greater than this function g of n, so again c is our constant, so therefore I can replace with the greater than 0 value. So therefore substituting the values of c is 1. If I substitute value for c equals to 1, then our equation becomes 3n plus 2 greater than equals to c of n, and c is replaced by 1, so therefore it becomes 3 of n plus 2 greater than n. So which is satisfied? Since 3 of n plus 2 is greater than n. Why it is satisfied? If I take n equals 1, so this side it becomes only 1, and in this side LHS it becomes 3 into 1 is 3 plus 2 becomes 5. So 5 is always greater than 1, so therefore it is satisfied. So this is simply a proof of omega. Next we'll see asymptotic notation theta. So now in theta, as you can see in the graph, there is three function. So first one is function with constant c1, and second one is f of n, and third one is function with constant c2. So from this we can clearly say that c1 of function gn must be less than equals to f of n, and again at the same time f of n must be less than equals to c2 of g of n. So this is what this graph represents, where we can say that this function c1 of gn, which is lesser than f of n, and again at the same time f of n is lesser than c2 of g of n. So Here C1 and C2 are again my constant which have values greater than 0, and n is number of input. You have to choose n in such a way so that c of n, c1 of g of n must be lesser than f of n, and at the same time c2 of gn must be greater than f of n. So that is how theta works. So this is overall picture of asymptotic notation, big O, omega and theta. Thank you for watching this video. Don't forget to subscribe this channel.